Parallel arrays. Parallel arrays are two or more arrays of the same length where the elements are conceptually linked by their subscript. Just like an Excel spreadsheet. You have months and then you have sales. Well, row 1 would have the month name, January, and the sales, $200 for that day, month. Not a very big business. Row 2 would have February and their sales, $800. Row 3 would have, March and their sales. Something like that. Something that would look like this if we allocated it. So we could have strings called month, and we might set it equal to, January, February, March. And then we might have floats or doubles called sales equal to, $100 on January, $500 in February, $200 in March. Like that. And so if we were going to print them out, C out month subscript 0, followed by a space, or space $sign, just to look really cool. Put a $sign there, arrow, arrow, and then the sales at subscript 0, followed by an ENDL. And that way it'd say Jan space sales, or Jan space $sign 100. Well, let's print out all 3 months. January, February, March. Just doing a little bit of cutting and pasting and changing of the subscripts, like that. When we ran it, it would say Jan 100. What's February sales? 500. And in March, 200. Yep, just like that. Now normally we'd be reading some of this data in. We'd actually use it to enter January sales or February sales or something like that. Also, whenever you see a sequence of numbers like that with 0, 1, and 2, you know that you probably would replace that with a loop. And in this case, you would not use a range-based loop. Why? Because a range-based loop does not give you an index number. And we need the index number to unite the two. We need that index number so that we can put, same number there and there, or there and there, and there and there. So we'd have to use an index-based loop. For int I for index is equal to 0, I is less than the length of the array. I'm just going to hard code it for 3 right now and be lame. Plus I. And I'm just going to steal this line that I copied and I'm going to paste it, but I'm going to replace the subscripts with I. And it would print out the same thing. All right. Other times I do different examples, right? Like colors and, colors of whatever. The kid and his favorite color, or, some person's name and their student ID, or the birth date, and that kind of stuff.
Quick question.
Yes, sir.
What's the I in there, right?
It should have been I and not 1. What kind of idiocy was I doing there? Thank you very much. All right. Much better. Much better. Okay. So that's a parallel array. Let's see their definition. Mine is 2 or more arrays of the same length where the elements are conceptually, and you could leave that word off, conceptually linked by their subscript /index. Two or more arrays that contain related data. Well, that's pretty short. Oh, fine. I'll paste that in there as well. Book definition. That's pretty dang vague. I can think of arrays that contain related data that are not parallel arrays. And I'll give you an example of that. Say you had an array that indicated the department that somebody worked in. Departments is equal to 0 is financing. 1 is sales, and 2 is engineering. And then you could have another array where you had a list of people, employees. And I haven't made this correct. That and that. And we have Bob and Jim and Sue all working there. And then we have what departments they work in. So the employee department. Bob works in department 0. That's finance. Jim works in engineering, department 2. Sue works in finance. Let's add one more person. Ned. Ned is our only salesman. Now, do you see what I mean? These two arrays are related to each other, but they're certainly not of the same length. They're not parallel arrays. These two are parallel arrays. They're of the same length. Bob and 0, and Jim and 2, and Sue and 0, and Ned and 1. But these are lookups, right? We have to look up and see what department 0 is. It's finance. What department 2 is engineering. We could write a little report that would do this perfectly, but it's not going to be just that simple little loop that we had where we were printing out something subscript I and something subscript I. We would have to reference this in a different way. We'd have to pull that number out and then use that as the subscript for that. Now that I've said all that, I don't know whether just to delete it or not. I think I'll just put a note here. Note. Departs, depths is not a parallel array, really. It's not the same length as the others. And it's not like Bob is in finance, and Jim is in sales, and Sue is in engineering, and Ned is in, whoops, we don't know. So anyways. And there's not a one-to-one correlation between employees and depths. Okay, hope that makes sense. If I was going to make this absolutely correct, this looks like an array of strings. This looks like an array of strings. And this looks like what kind of array? Ints. Be a good one for that. I'm almost tempted for us to do that. That's a pretty neat idea, but nah, let's leave that alone. All right, so parallel arrays. Conceptually, we could have as many arrays as we wanted to as long as they were linked. You know, F names, L names, IDs, you know, birth dates, you know, birth cities, birth, you know, and then current address city, you know, whatever, you know. Now, is this the best way to correlate your data? Probably not. It'd be better to make a class, perhaps, that had a first name and a last name, and each patient had a first name and a last name and an ID and a birthday and a birth city and a current address and a current address city, that kind of stuff. That'd be a better way to handle it. But knowing what we know now, that'd be the way to handle it. That's the tool that we have available to us, is a parallel arrays. You could have a lot of parallel arrays. I'm not going to type in examples of each one, right? That'd just be tedious. First name is equal to Joe, last name is equal to Bob, their ID is 1, their birth date is what, you know. I think you get the idea. Here's their example. They declare their array of size 5. They have an array of IDs, which is ints. They have an array of averages. And then they have an array of grades. And then they do some kind of processing where they fill those things in. They didn't initialize these, so we don't know what their IDs are. We don't know what their averages are. We don't know what their grades are. So then a miracle occurs, right? That's that step. And then now we can process it. We can display the results. We have a for loop, and we print out their ID subscript I, their average subscript I, and their grade subscript I. I kind of want to do that one. This is a more classical example than the one that I usually do, which is where we have employees and we have their hours and we have their pay rate and we calculate their total pay. Tired of that example, so I want to do the grade example. We're going to pre-fill, but instead of making an ID, we're going to do names, just because names are more fun. And we're going to ask the user for their average of each name, and then we're going to assign a grade based on their average. We're not going to make it real exhaustive. We might give them an A, B, or an F, something like that. And then we're going to loop to print all that stuff out. All right, I have the idea that we're going to be adding a lot of code today, so I'm going to try something a little bit different. Empty project, July 18. Source file, add, new item. CPP file, July18.cpp. Good old boilerplate. I'm not going to even read it aloud. All right. Here's what I want to do, is to pop up a little menu right at the beginning and then ask ourselves which thing we want to do. Because you know how I keep doing it, we keep shoving stuff up in main and we keep shoving stuff up in main and it never, it gets really messy. So here's what I want to do. Cout 1, 2, or 3 \n. And then int choice, cn arrow into choice, and if parentheses choice is equal to 1, we're going to call code 1, whatever code 1 is. We haven't written code 1, but we're about to. And then later on, we're going to create a code 2, and so we'll extend our logic. If choice is equal to 2, run the code 2 block, and if choice is equal to 3, run the code 3 block. Hopefully that'll make our code a little less messed up, too cluttered. Because whenever we do these things and we ask for user input and then we keep testing it and we have to enter user input every single time, kind of nasty. Okay. So let's write our code 1 function. Void code 1 in parentheses, We're going to declare 3 arrays. An array of names, an array of scores, and an array of grades. Let's declare a constant for how many we have of each. So const int a size for array size is equal to 5. Now we need names. Names would be good for strings, or strings would be good for names. So string names subscript a size, and then there's score, integers or doubles. I'm going to make it a double. Double scores subscript a size. And then string grades subscript a size. 5 names is going to be too many. I'm going to shorten that to 3. I don't want to have to type in that much data while we test it. We could always increase it. We could ask the user. All right, now we need a little loop. For int I is equal to 0, I less than a size, I plus plus, that kind of business. For int I is equal to 0, I is less than a size, I plus plus. We need to ask them for the name, we need to ask them for the score. So we need 2 variables to hold that stuff. String n is going to be my name variable. Int s is going to be my score variable. Now our program's not going to be real great because it's not going to allow them to enter first and last names. It's all right. We know that we would use getLine if we wanted to let them enter first and last names, but we also know that that kind of conflicts with using CIN to read in, a numeral for score. So for simplicity's sake, we're going to only do single names while we test it. Alrighty, so cout student name equals, or student name colon, space end quote, semicolon, CIN arrow n. Then do the same thing for their score. Cout score colon CIN into S. You know what? We don't even have to use these temporary variables. We could read directly into the array. But I'm not going to change it. So cout arrow score colon CIN arrow S. Now we have our data, we can store those into the arrays. So the next 2 lines, name subscript I is equal to n, score subscript I is equal to S. Name subscript I equals to n, score subscript I is equal to S. We're not going to ask them for the grade. We could calculate it right now, or we could calculate it with a for loop later. I'm going to save the calculation of the grade for later. All right, when this loop is done, we're going to have an array of names and an array of scores. Maybe we ought to write the printing of that just so that we could test our code. All right, so I'm going to scroll down a little more. This is going to be outside of the for loop. This is our data input loop. And now we're going to have a data output loop. So for int I is equal to 0, I is less than a size, I plus plus. Let's just cout names subscript I, whoops, followed by arrow, quote, \t, end quote. We're going to put a tab there. Followed by their score. Arrow, scores subscript I. Arrow, \t. Now I'm going to wind up putting more data there maybe, right? We're probably going to have a 3rd column for their letter grade. I'm just going to leave that there, and on the next line I'm going to print out the \n or the ENDL. I'm just thinking ahead. I know that I'm going to be printing out more data. Okay, that's probably enough to test our code. I'm going to do so. All right, 1, 2, or 3. Well, I only have one module implemented. One. Student name. Why don't I blow the size of the box up first? All right, student name, Joe. His score, 90. Student name, Bob, made an 80. Student score, their name, Sue, made a 95. And then we print out our cute little table. Joe made a 90, Bob made an 80, Sue made a 95. We're going to need another loop that goes through and fills in the letter grade. So we're just going to have one more for loop. But before we do that, I want to make sure that we're not getting too far ahead, because I don't want 20 pages of code while people are still typing stuff in. A couple of changes I would probably want to make is when I say score here, I would probably want to put the student name there, so that if they typed in Bob, then it would say Bob's score. That's called echoing the input. But I'm not going to make this example more complicated than it needs to be. But I want a for loop to calculate the letter grades based on the scores. So I'm going to copy that for header, paste it, give myself some curly braces within which I will type. This is between our data input and our output loop. So we have a processing loop. Common programming paradigm. Data. Get your data, process it, and then display the results. Alrighty. We just need to figure out their letter grade. And I guess I'm going to store that in a string. I'm just going to call it letter. String letter. And I'm going to create an empty string, but then if I calculate a letter grade, I'm going to fill that string in. And this is just going to be one of those if grade greater than 90, letter equals A. Else if grade greater than 80, that kind of business. So if parentheses, well, what is my grade? I have to do scores subscript I. So if scores subscript I greater than equal to 90, they made an A. So if scores subscript I greater than equal to 90, close parentheses, letter is equal to A. Now, because I'm lazy, I'm going to copy and paste that a couple of times. But I'm going to have to put else in front of the other ones. So else if scores greater than or equal to 80, they made a B. Else if scores greater than or equal to 70, they made a C. Else if scores greater than or equal to 60, they made a D. Else letter is equal to F. That should do it. Except I have to copy that letter grade back into our letter grade variable array. What did we call our array of letters? Yeah, it was called grades. So grades, subscript I, is equal, single equal, not double like I typed, letter. I'm going to have to modify my output loop to print that as well. But that's going to be pretty easy. I'm just going to add one additional cout statement between those other two. You can do that before I do it if you want. Before that ENDL, do cout arrow grades subscript I. So I'll do that. Between my two cout statements down here in the for loop, cout arrow grades subscript I. Another parallel array example might be some kind of inventory, or how about a grocery receipt? where you print the name of the item. They bought eggs. You put how many cartons? 3, and then the cost per carton is $1.99, and so you print the total price there. And you keep doing that. So you'd have several parallel arrays. One would be for the name of the item, one would be for the quantity purchased, and one would be the price. And maybe we'd even create one for the total price of that particular line. We might do that one as skipping the data entry stage. All right, I'm itching to test this. I'm going to give it a shot. One, 2, or 3. 1. Student name, Joe, 90, Bob, 80, Tim, 92. Joe, Bob, and Tim made an A and a B and an A. All right, our parallel arrays are working. If we had all the time in the world, I'd want to make a program that would display an ID number by each name, just number them 1, 2, 3, 4, 5, 6, 7, and ask the user what they want to do. Do they want to add a new record, or do they want to modify an existing record? And if they chose modify, we'd ask which line number to change. And when they chose which line number, we'd let them type in a new name, or hit enter to keep Bob, and we'd let them type in a new score, or hit enter to keep 80. That'd be kind of neat, but that'd take the rest of the day, so we're not going to do that. Let's do another parallel array. Now let's do a summation loop. I'm not sure that we've done a summation yet. Well, actually, why don't we just go to the PowerPoint and start going down? Arrays as function arguments. Well, that's kind of like a big deal, because if you pass an array to a function, it's just the same array. Might have a different parameter name, but it's the same array. You could treat it the same way. Let's give an example of that. We're going to create a code 2 block now. So the first thing we need to do is go down here, and where we're in main and it says choice 1, 2, or 3, why don't we modify our cout to indicate what each block does? 1 is equal to code 1. 2 is equal to code 2. All right. We haven't implemented 3 yet, so I'm not going to fill in anything for that, although it's pretty obvious where it's going to go. So, and then underneath our if, else if, parentheses, I'm getting the urge to make this a switch case. I'm going to delete all that stuff, all of our if-elses. Switch, parentheses, choice, end parentheses, curly brace, case 1, colon, code 1, parentheses, end parentheses, semicolon, break. Case 2, colon, code 2, parentheses, end parentheses, break. We don't have code 2, so it's underlined, but we will. And then a default. If they choose something that we don't have implemented yet, then we're going to print out an error message. Cout, invalid choice. Now, if we were totally awesome, we'd put this in a loop so that we could keep rerunning it, but I don't think that's necessary. We can always just click the run button again. Alrighty, I actually want to write the code 2 block now. So we're going to come up here, let's make it void, code 2, in parentheses, curly brace. Let's just allocate an array, doesn't matter what it is. Colors, or string colors. How many colors do we want? We just want 3 colors. Is equal to, we should declare that as a constant, I'm going to leave that idea alone for now, is equal to curly brace, and let's type in 3 colors. Red, comma, gold, comma, silver. Now let's call a print function. Well, gosh, we haven't written the print function yet, but here's what it's going to look like. Print colors, parentheses, and we're going to pass our colors array into it, in parentheses, semicolon. And of course, print colors is underlined in red because we haven't written that function yet. We can do that. I'm going to go above the code2 function and define a print colors function. Again, I'm going to just make it void. All we're doing is printing. We're not adding anything up and returning anything. So void print colors, parentheses, and this parameter is going to be an array. String colors, subscript in subscript. Now we don't know how many colors are going to be. And by the way, we have a problem. I'm going to have to make some changes. I'm going to make the change right here and then go back and modify where we call, because I know in advance. We need to do int size. Why? Because there's no other way for this function to know how many colors there are. That's not absolutely true, but it's true enough. That means that down here I need to specify how many colors we're printing out. So I'm just going to tack on a comma 3 right there to our print colors call. And now we need a loop that'll print out that array. We tend to write the same loop over and over. For I is equal to 0, I is less than, in this case, I size, I plus plus, and then some kind of print statement that prints out colors subscript I. How to make y'all do that? But I'm going to go ahead and do it. So cout, arrow, arrow, color, space, end quote, arrow, arrow, I forgot my for statement. This is kind of dumb. I'll have to go and put the for line above it. I'm going to finish typing this line. Arrow, arrow, I, arrow, arrows, quote, space, is, space, end quote, arrow, arrow, and now we're going to actually print the colors out. Colors, subscript I, arrow, arrow, India. I'm going to break this up into multiple lines because I think that's getting hard to read. Who knows, that may be harder to read. But I don't have my for statement yet. If you're feeling adventurous, go ahead and add the for loop above it. For I equals 0, I is less than I size, I plus plus. For int I is equal to 0, I is less than I size, I plus plus. All right, now when I run it, it's going to say color 0 is red, color 1 is gold, color 2 is silver, unless you chose different colors. I'm not digging that 3 there, though. That's what's called a magic number, right? So instead, I'm going to want to calculate the number of colors on the fly. And unfortunately, I can't calculate the number of colors right here inside this function. You have to calculate it in the same scope in which you define the array in this language. Java is a completely different thing. So is Python. So let's calculate. Let's take that 3 out from here, and let's calculate I size. Int I size is equal to, and we're going to do that size of array divided by size of string. So int I size equals size of, parentheses, and the name of our array is colors, in parentheses divided by size of, parentheses, string, in parentheses. And then we're going to pass that into print colors. Now, why did we write print colors as a function rather than just do that right there underneath that allocation? Just because we're on the PowerPoint that's talking about passing arrays as functions. But we could make this more generic. We could make this function not specify that it's a color, and then we could use it to print any array of strings, in which case it actually is a useful function. And let's run it. All right. Code 2. Color 0 is red, color 1 is gold, color 2 is silver. Do you remember our little project where we were calculating the mass of a sphere based on its volume and density of the material? We had a list of materials by name, and we had a list of densities. Those would be perfect for parallel arrays. I think that's going to be the assignment. Maybe. We'd have to set that assignment up. We'd have to do a little bit more. We'd have to do a little bit of work here. Alrighty, so anybody need typo assistance? Alrighty. So we've started a new code block. Better pause it and type it in, because I forgot to start the recording 2 minutes ago. Code block 3. We define void code 3. We've defined our array size, constant a size equals 3. We've defined our first array of names. And by the way, thank you very much for reminding me to get the recording on. All right, and now an array of ages. I'm going to make them floats or doubles. Doesn't matter which. Double, ages, subscript a size, in subscript is equal to, what, who knows? Bill Gates is 61. Steve Jobs, he's dead, so what's the age of a dead person? I don't know. We're going to say he's 67, and Mark Zuckerberg is 32, and I have no idea of the real numbers. Let's create a little program that displays these people, and based on what they choose, we display their age. So just a little menu. So I'm going to make a variable called choice. I'm going to set it off as equal to 0 just for lack of a better choice. But it's going to have a sentinel value. If they type in choice is equal to -1, we're going to bail out of the loop. So that's our sentinel. While choice not equal -1, while choice not equal to -1, what's the first thing we're going to do? We're going to display some kind of message. Or let's just display all the names first. But let's also put numbers in. And Zach, I'm curious as to whether you're going to do the +1 and the -1 trick or not. I'm not going to at this point. I oughta. Okay, so I just need a little for loop to print out the names. And I need to make it an index-based for loop so that I have an index counter to use. Why? Because I have parallel loops. Anytime you have parallel loops, you have to use an index-based counter. So for int I is equal to 0, I is less than a size, I, or plus I, and then C out the number, so I, arrow, arrow, and then their name. So names, subscript I, arrow, arrow, ENDL. After our for loop, we're going to display our menu prompt. Enter the number of the person you want to view. Something like that. So C out, arrow, arrow. enter the number of the person whose age you want to see. Or let's change it a little bit. Enter the number sign of the person to view. That's good enough. You could word it better if you want. Colon, space, end quote. And then I'm going to CIN into choice. CIN error choice. I need to make sure this is valid input. But the first thing I need to do is to rule out -1. And I didn't tell them they could type in -1. So I should modify my cout statement to have that. So I need to come back up here and modify this a little bit. So where it says, enter the number of the person to view, comma, or -1 to stop. Then we read into the choice. Let's validate the data. But first, let's make sure that it's not equal to -1. If parentheses, choice equals -1, in parentheses, cout, okay, goodbye, \n. So really we need to make sure it's between 0, 1, and 2. So we need to make sure that it's greater than or equal to 0 and less than a size. So else, if choice is greater than or equal to 0, ampersand, ampersand, and choice is less than a size. And Zach, if you are doing the +1 business, you're going to have to make lots of changes here, but it's way cooler to do it that way. And what I'm talking about is that Zach made it say numbers 1, 2, and 3 for the colors, not 0, 1, 2. And that'd be neat for this, right? The user doesn't know why they're typing in 0 for somebody's name. They'd rather see it start with 1. And so when you do that, you'd be adding 1 to it there, and then when you get their choice, you'd subtract 1 from it, that kind of business. But I'm going to skip that. Get it working without that kind of enhancement, and then go back and change it. All right, so if that stuff is accurate, then let's actually do something with it. You know what? I'd rather give an error condition first, so I'm going to change the logic. If choice is less than 0, or, so vertical bar, choice is greater than or equal to a size, then it's an error. Cout error, invalid choice, \n. And I'm just going to use a continue statement. I know we've talked about continue. That just forces the loop to reiterate. I wouldn't have to do that. There's no reason to do it. Maybe I'm going to take it out. I will. And this one could be a break, right? If they choose -1, we could break out of the loop. Okay, I'm going to do that. I'm feeling like doing that. Not the best programming, actually. Why do I say that? Usually you should try to organize it so you only have one way out of a loop. And right now we're providing 2 ways out. There's going to be a break statement. I'm okay with it. All right. Otherwise, if they didn't type in a -1 and they didn't type in something less than 0 or greater than or equal to a size, then we're good to go. Else, parentheses in parentheses, cout, no, I'm not going to cout anything. We have a valid choice. That's just my comment. Let's get their age. Double person age equals ages subscript choice, because that's what they did. That's what they typed in. They chose which person they want. And then string person name personage. That looks funny. That's a real English word. All right, but anyways. Person age is equal to age's choice. Person name is equal to name's subscript choice. Now we can print that information out. C out person name subscript, or yeah. C out person name arrow is person age years old. So C out person name arrow quote, and then the word is space end quote arrow person age arrow space years old. And that's getting too long on my screen, so I'm going to break it up into 2 lines. \n. I misspelled person name here, so I need to correct the typos in my program. Person name should have 2 N's. What would be really cool is if I used a capital N to make it easy to read, or if I used underscores. So I'm going to do that. Person underscore age, person underscore name. I need to modify my code to match. Person underscore name and person underscore age. Does anybody see my syntax error here? Why is it underlining person underscore name?
So you didn't put the 2 arrows?
Exactly. I don't have the arrows. I don't have the stream insertion operator. Let's do that. All right, that ought to do it. I could put a little end while comment here. And I could put a end function comment down there. This function is getting big enough that I kind of like the idea of putting comments like that to let me know where I am in the code. I need to go and modify the case statement, add a case for 3 to call code 3. Feel free to go ahead and do that if you've got the rest of this. I am going to make a few changes to the code to conserve space. I've decided that's my new favorite way of setting up braces. All right, before I can test it, I actually do need to modify the case. So I'm going to scroll down there and do that rather than wait. If you're looking at this code and still typing, I apologize. I'll scroll back up to it in a minute. All right, so go down here to your switch cases and add a 3rd case. Case 3 colon. And if you've already done this, run it and test it. Code 3 parentheses in parentheses break. All righty. Give it a shot. All right, I need to modify my little menu up here. I didn't say what 3 was, but we know what it is. All right, so Bill Gates, Steve Jobs, Mark Zuckerberg. I could have done a little bit better formatting there. I might do 0 equals Bill Gates, 1 equals Steve Jobs, 2 equals Mark Zuckerberg. Enter the number of the person to view, or -1 to stop. I'm going to just type in -1, make sure that that works. Okay, goodbye. Okay, great, that worked. Run it again. Choice 3. I'm going to type in some invalid data. 55, invalid choice. -20, invalid choice. All right, I give up and I'm going to start choosing good values. 2, supposedly Mark is 32 years old. 1, Steve Jobs is supposedly 67 years old. 0, Bill Gates is supposedly 61 years old. Who knows? All right. That works. Now, do you see the applicability of this to our densities problem? What are your 2 arrays going to be? It's not going to be names and ages.
Materials and densities.
Right. You're going to have 2 parallel arrays, one for material name and one for densities. You're going to let them pick the material based on number, If you really wanted to be way out, you could let them type in the name, but it's easier for somebody to just pick element 3 as aluminum, you know, type in 3 for aluminum rather than spell out the whole word aluminum. I'm going to go back up to the top of the module and then scroll all the way down, and then I'm going to do some walkabout, make sure y'all are okay. So for the purposes of the people watching at home, there we go. Function definition, definition of our arrays, setting up our while loop. And this code would work just as well if we got rid of the break and if we got rid of the continue. I just kind of threw that in on a whim to kind of make the code a little bit more bulletproof so that if you started putting code in the wrong place, those two things would still manage to work. And then our while loop, while choice is equal to -1. We had a for loop to print out the names. I'm going to modify this. I don't like name subscript I. I don't like the 0 being right next to mark. I want some kind of space there. So name subscript I, arrow, arrow, quote, space, equal sign, space, end quote, arrow, arrow, like that. I think that'll just make the little menu look a little better. All right, so we had our for loop. We got our input with a cout and a cin. We had choice equals 1. Okay, goodbye. We had choice is equal to 2. Invalid choice. And else, and that's where the big block of our code is, but it's actually pretty small. And we added a couple of closing braces after that.
Where did you put the equal sign again? I'm sorry.
I put that right here. Where did I put the equal sign? I modified this top print statement up at the top of the while loop, just because I wanted to make it prettier. It worked okay without it, but it was kind of ugly.
That's not going to put it between the number and the name, though. That's going to put it to the end.
Oh, you're right. That's in the wrong place. Okay, then. I'm going to cut that out. And I'm going to come and paste it in front of names. Yep. Good catch. Alrighty. Run code block 3. Yeah, I like that. 0 equals Bill Gates, 1 Steve Jobs, 2 Mark Zuckerberg. Okay. Nifty. Let's go ahead and take a break, get back together at 8:30. If you need me to scroll the code up or down, or you need my eyes, just a second, I'll come help. Oh man, it's been recording all the time. I'll have to cut that section out. All right. Yes, sir. Need typo correction?
Yes.
All righty. So a little notice that I posted here is if you're going to take Java next semester from me or even from somebody else, you're going to want to install what that instructor wants you to install. But I always have you install NetBeans. So if you feel like sneak preview, feel free.
I had a question.
Yes, sir.
About, there's a course that's, it says it's the advanced course in C++, but it's called like Program Implementation Development or something like that. I didn't see it offered in the fall.
Okay.
Do you know if that's going to be offered in the spring?
Very good question. If you don't mind, either text me or email me, and I'll ask the division dean, or I'll ask the academic advisor, if when's the next time it's going to be offered. So if you could send me the class number and name, I'll find out. All right, so passing arrays as function arguments. It works just like you'd expect. You could pass in an int, or you can pass in an array of ints. Notice that in the prototype, you also had to declare it as being an array, but you didn't have to give it a variable name. Same rule about prototypes. You don't have to give the variable names, but I think they are useful information. If we didn't have this here, and all I had sitting in front of me was this show scores, I might be able to div in that, oh, that's probably the array of scores, and that's probably the array size. But gosh, wouldn't it be better if I had scores there and size there, I would immediately know what I was going to pass to it. Right, so variable names convey useful information as long as you pick good variable names. So I see no reason to hide them, to remove them from my prototypes. Now we've been talking about pointers and references and stuff like that, and previously we've said, it passes by copy, so it won't be able to change the data. Well, then why is it able to change the array? Not that we've tested that, but it's true. If we went into our code, we could write a little function like this. Don't even necessarily do it. Void test, that took an array of something, maybe an array of strings. I'm going to call it SA for string array. And then SA subscript 0 equals Bob. If we called test, sorry, I did a Java declaration. I need to move those square braces. If I called that, created an array of strings, and then printed out the name, the array, it would print Bob. I could prove that. I could go down to this list of names here and do test and pass my array of names there like that into it. I'm going to undo all these changes. But what we're going to see is that when it prints it out, it's going to say Bob instead of Bill Gates. It changed that data. And we've already talked about the fact that if this said int x, and we said x is equal to 999, something like that, and then we printed out x down here, it wouldn't have modified it. So what's going on? Why does that work? The reason why it works is that, sure, it's just copying the content of this into this, but what is the content of it? An array is really just a pointer. It's just got a memory address to an area of memory. And so this just gets a copy of that memory address. It uses that memory address to access the array. So it doesn't matter whether it's a copy of the memory address or whether it's the original memory address. It's like I write down my home address, 123 South Main, and then I give it to you. You can still use that 123 South Main to go to my house and break in or whatever. So by passing in a copy of the memory address, we still have the ability to change the data that memory address points to. And that's how stuff like this in Python managed to work without you really thinking about it too much. Python is also a pass-by-copy language. But it didn't matter. If you passed a list in to a function that you defined in Python, then that function could change the data in it for the same reason. It's just passing an address into it. It's passing a copy of the address, but it's just an address, and then it can go and use that address to modify the data. Hope that kind of makes sense. You don't have to define the array as a reference. Oh, neat. An array of reference is not allowed. Okay, you can't. When I say you don't have to, in other words, you better not. Okay, so it looks like an exception to the rule that it's passed by copy, but it's not. Similarly, in Java, when you pass things into an array, if you pass an object in to a function, it can change the contents of that object. It cannot create a new object, though, and then assign that address, because that would actually be changing this value. It would be putting a new address in it. So we'd be changing the value of it. This guy's not going to pick up that change. So just remember that pass by value or pass by copy when you go on to take other languages or when you're working here does not mean that you can't change it if it's an array or if it's an object. It just means that you can't change it, or that you can't change the data that it points to. All right. Hope that's clear as crystal, not clear as mud. Modifying arrays and functions. You can do that. Array names are like reference variables. Any change made to the copy of the reference is reflected in the actual array because they're both pointing to the same thing. No matter how many copies of my street address I hang out, they all point to the same house. No matter how many street signs I have pointing to the particular street I live on, they all point to the same street. So you have to exercise caution that the array is not changed by the function unless you want it to be. Are there ways to fix that? Could I use the word const here to forbid them from changing the contents of the array? Let's see. Yep. So if I define this array as const, that's telling this function, it's telling the compiler, don't let them write any code that would change that. Now, does that make that data super safe from modification? Not really. It's just for the programmer. The programmer won't be able to write code that'll change it. It's not like it makes it more secure or more, less vulnerable to corruption or anything like that. It's just to help the compiler. It stops you from writing anything in here that would change that data. So that's not a bad idea. Use const in order whenever you're passing an array in, but you don't want the function to be able to modify it. So everywhere I've passed in an array, like in print colors, I ought to define that as const. I'm not going to be changing the colors. Do I pass in any arrays anywhere else? No. I have typed in so few notes here. Oh well. Passing an array to a function. When you pass an array to a function, the parameter is a reference to the same array. You must take care not to inadvertently change, use their words, change the data. I'll spell check later. Change the data in the array. To prevent that, you can use the const keyword. Void change it, or just void function, and it takes, say, an array of ints, like that. We would be able to do this, array subscript 0 is equal to 1, 2, 3. But if we say const int, then the compiler would flag that as an error, because the array is marked as const. Two-dimensional arrays. You've seen two-dimensional arrays. If you played that old game Battleship as a kid, E5, you sunk my battleship. That's a two-dimensional array. You've used Excel. You've got rows and columns. That's a two-dimensional array. You play tic-tac-toe. Anything that's a grid, anything that's a matrix is a two-dimensional array. So the way you define your two-dimensional array is you don't just give it one size, you give it two sizes, the number of rows and the number of columns. The first declarator, the first thing between the braces, is the number of rows, and the second one is the number of columns. So this would just create a 4x3 array. How many elements would a 4x3 array have? 12, yeah. Not 7, not adding them up. 4 rows of 3. Like this. We could create an array of exams. Not sure why we're creating an array of exams, a two-dimensional array of exams, but we are. And we decided it's 4 rows by 3 columns. To get a hold of that element right there, you access element 0, 0. To get a hold of that one, you access element 0, 1. This one's going to be 0, 2 because it's row column. So this is row 1, column 0. That's row 1, column 1. This is row 1, column 2. All the way up to row 3, column 2. They're both 0 based. Your rows are 0, 1, 2, and 3. Your columns are 0, 1, and 2. This program demonstrates a two-dimensional array. We're not going to use their code. We're going to use our fourth. So we're going to do a code for block. So we may as well add that onto our cases first. Case space 4 colon. Can I type a colon, please? Yep. Code for. I'm kind of fond of the way we've set this up, providing a little bit of order. Break. Now it's giving me grief for one thing, because I typed a colon there rather than a semicolon. And another is because I don't have that function defined yet. Alrighty, I'm going to scroll back up and create a code for function. Void code for parentheses in parentheses. We need a two-dimensional array. I'm going to create a silly one first, kind of like a tic-tac-toe board. It's going to be a two-dimensional array of strings. I'm going to call it TTT for tic-tac-toe. I should put size declarators here, 3 and 3, but I don't have to because I'm going to use initializers. But I'm going to do that anyways. Now this declaration is going to look a little bit odd, but just roll with it. Put your curly brace there and a couple of lines of free space, white space, and then a curly brace and a semicolon. And then inside that white space, do something like this. We're going to put x, comma, o, comma, x, appropriately surrounded by commas and quotes. And then outside the curly brace, put a comma. Go to the next line and type in something similar. Quote, o, comma, quote, x, comma, quote, o. Then you close your curly brace and add another comma. And then lastly, maybe an X and an X and an O. Now we're not going to actually program a tic-tac-toe game, although that's kind of fun to do. All right, let's print out our tic-tac-toe board. To print out, to utilize, to access a two-dimensional array, you use nested loops. And if you think about it, that's what we do in real life. We just don't think about it. Like if I'm going to have one loop that accesses each row, and then inside that, I'm going to have another loop that accesses each column. Just like if you were typing this data, you'd start typing on one row, and you'd type in column, 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 and you hit enter. That exits that enter loop. And then it increments the row number. And you type in column, 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 and you hit enter, and it goes to the next row. Column, column, column. So you're doing each series of columns before you skip to the next row. That's what our nested loop's going to do. So for int r is equal to 0, r is less than 3, and it's really lame to be hard coding this magic number in it. r plus plus. For int, for parentheses, int c is equal to 0, c is less than 3, c plus plus. And let's print out TTT subscript r subscript c. And I'm going to make a mistake here that we'll go back and fix, just so I can ask you what I did wrong. C out, arrow, arrow, TTT subscript r in subscript, subscript c in subscript, semicolon. And then at the bottom of our code, return out of it. Now this isn't going to do exactly what I want. Let me show you what I mean. When I run it, okay, it doesn't do at all what I want. Why don't we go look at our error list? Oh, yeah, when I was showing not what to do. Let me fix all of that stuff. I hope you didn't type it in. What am I having to do if you type this in at home? Remove that void test function and then remove the call to that test function. And then everything's going to be much better. All right, let's go back up to my tic-tac-toe board code. There he is. run it. Build, rebuild solution. Local. Oh, neat. I forgot to say that they could run code block 4. Our little menu's getting sloppier and sloppier. 4. Alrighty. Is that what I wanted my tic-tac-toe board to look like? What did I do wrong?
You didn't put a C out ENDL at the end of the R loop.
Right. Right. I want to print out an end-of-line marker after I've printed out all the columns. Right? I want to print out column 1, column 2, column 3, and then I want to hit enter. And then column 1, column 2, column 3. So that's going to be outside the inner loop because I want to do all the columns. And then, so here, do a C out ENDL right there. That'll fix that. All right, it's bugging me that my menu is inaccurate. I'm going to come down here and fix my menu choices. 1 equals code 1, 2 is equal to code 3, 3 is equal to code 3, 4 is equal to code 4. And that's so informative. I should put 4 equals two-dimensional array, 3 is equal to blah, 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 but that's enough. All righty. Once more with feeling. All right. There it is. There's my little tic-tac-toe board. What if I wanted, before I print it out, what if I wanted to change that element to like a question mark? What are his indexes going to be? Well, what row is he on? Second row is index what?
2 or 1.
Exactly. So it's going to be index 1 for the row, and what column is he in?
2.
Yeah, 0, 1, 2. So I'm going to do that right here before I actually print it out. Tic-tac-toe. I've already forgotten what I said that was going to be. Did I say 1? Okay, and then 2. Nope, 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 that's wrong. TTT subscript 1 in subscript, subscript 2 in subscript equals, quote, question mark, double quote in semicolon.
Should be 1, 1, right?
I don't remember which one I was trying to change, honestly. There. I think that's the one I pointed at. So I'm trying to change that one. That is row, if that's row 0, that's row 1. And then inside there, that's column 0, 1, and 2. Okay. So I'm happy with that. That makes sense? We're good? Okay. Okay, so you can kind of see that an array, excuse me, a two-dimensional array is an array of arrays. I would have to Google up how to get the size, the number of rows and the number of columns. How to get number of rows and columns of 2D array in C++. Check Stack Overflow to get the most cryptic, obnoxious answer possible. Yeah, here we go. Is there a better way to do this? Yeah, use a different data type. Use a vector. Okay, see, that didn't tell us how to do it. All right, and then here we go. You use some decal type arrays greater than, okay, so forget it. We're just going to define constants. Replace these 3's with constants. Maybe we're going to use pound sign defines just because we haven't been doing much with macro definition. Pound sign define rows space 3. Pound sign define calls space 3. And so replace that first 3, the one that means rows, with the word rows. Replace that second 3 with calls, and then do the same thing down in our nested loop. That first for statement should have the word rows as its less than, as its comparison. And the second one should have calls there. All right, hopefully that'll work. Have we even done this ever? The pound sign define rows and calls? Okay, good. We know not to put semicolons here. Why? Because then when it expanded it, it would put semicolons in my thing here. Obvious syntax errors. So we're going to take that out. Same reason you wouldn't say rows equals 3 or calls equals 3. Because these are just macros that get expanded. So when it did that, rows would be replaced with the word equal 3. Calls would be replaced with a word equal 3. Not good. Okay. I'm not sure what else I want to do with that example. Copy your little TTT array here, just for speed of typing. Highlight all that, copy it, come down to the end. Before you return, if you put one there, paste it and call it A2D for array 2 dimension. And fill these with numbers rather than strings. Like, I don't care what the numbers are. 3, 4, 6, 7, whatever. And it better be ints rather than a string. Doubles would work too, but I'm going to make it int. So change the type of that array to int, the name of it to A2D, and change the data to all numbers. Now on your own, write a nested for loop that'll print that array out. First, let's compile that, make sure that's not a blatant error. Okay, good. Not a blatant error. Yeah. So go in, pause the recording if you're doing this at home, and write a nested for loop. Yeah, could you just copy the other one and make one change? You sure could. Alrighty. Fastest way would be for me just to do a copy and paste, but it builds strength to do it by hand. So for, except I'm going to call it X and Y rather than R and C just for the fun of it. Don't do that if you've already come up with your own solution. Int X is equal to 0. X is less than capital rows. X plus plus. The inner loop for int y is equal to 0. Y is less than rows. Y plus plus. And then cout, arrow, arrow, A2D, array 2-dimensional, subscript X in subscript, subscript Y in subscript. And there may be a tab between them. I don't know. We don't have to. What if those numbers were larger than 1 digit wide? Then yeah, we would want to provide some kind of spacing. We could use IO manipulators for that. The set W command. I don't want to put an ENDL there. My mistake. Where should the ENDL really go?
At the end of the arm.
Exactly. It's got to be the end of my inner loop. Cout, arrow, arrow, ENDL. All right. Code 4 prints out my little array. All right. Some couple more exercises I want us to do. The idea of calculating the minimum value of an array, the maximum value of an array, the sum of an array. And the technique is the same regardless of whether you're using a 1-dimensional array or a 2-dimensional array or a 27-dimensional array. If you wanted to allocate a 3-dimensional array, you just tack on another declarator, right? 4-dimensional array. Okay, my brain starts hurting at the idea of a 4-dimensional array. But anyways, we could do that. How would you print it out? I don't know. So, whoopsie. I'm going to copy this, paste it down here in our notes, 2-dimensional arrays. If you weren't going to fill it with data, if you weren't going to initialize it, here's all you would do. But something had better go back in and assign values. You'd probably use a nested loop to put data into it at that point. Use a nested loop to display the array. Through the miracle of cut and paste, I'm going to get that code written amazingly fast. Okay, so to sum an array, a 1-dimensional array, what do you got to do? Same kind of stuff we did in fundamentals. You got to create your accumulator variable. Then you have to have your loop. And inside your loop, you add to your accumulator. Add element to accumulator. If it was a nested loop, well, you'd have a loop and then you'd have another loop. And then down at the bottom, we could use that accumulator for something, right? Calculate an average or whatever we cared about. That'd be a for loop. What if we wanted to find the highest value? What you do then is you don't have an accumulator. You keep track of a variable called highest. And you set it equal to the first element in the array. And then you start comparing every other element. And if that element is greater than your current highest, you set your current highest equal to that one. Right? So like if I had an array of numbers, I'd set my highest equal to the first number, but then I'd start stepping through the array. And if the next number was actually higher, I would write that one down as my highest. And if the third one was actually higher than that, So this is our sum code, or pseudocode, or whatever we want to call it, algorithm. This is our find highest algorithm. You set it equal to the first value, and then you have a for loop. And inside the for loop, if element is greater than highest, then highest is equal to that element. It becomes the new highest. Lowest is the same way, except you're not going to use greater than, right? You're checking for the least of them. So here's our find lowest algorithm. You create a lowest variable equal to the first element of the array, and then you have your for loop. And then if that particular element, if element is less than the highest, then wait. If element is less than what? I don't have a highest anymore. I have a lowest. If the element is less than the lowest, then it becomes a new lowest. Lowest is equal to element. All right. Have we written the summing code before? I'd hate to take the time to do it again if we have. I'm not recalling that we have.
We've had to sum things and then find averages. Is that what you mean?
Well, we did like scores, but did we sum an array?
No.
Okay. So let's do that. I guess we're going to start another code block. Code 5. Void code 5. And then go and add a case for that. So case 1, 2, 3, case 4, case 5, colon. Call code 5. Parentheses in parentheses, semicolon, break. All right, we need an array of numbers. It'd be awesome if we filled it in randomly, stuff like that, but in const int size is equal to 6. We're going to create an array of 6 numbers. All right, and then our data, our numbers, whatever they are. Int data subscript quote size, that's our size declarator, is equal to, and then just type in 6 numbers. If you're feeling ambitious and want to make more than 6 numbers, you want to make 200, whatever. Now let's do the sum. We need an accumulator variable. I like to make my accumulators doubles, just so that at the end, if I want to calculate the average, I don't have to worry about integer division. You know, we could fix that at the end, and it's probably more correct to do it as ints. Why not? Let's do it as ints. Okay, so int total is equal to 0, and then we need our nested loop. For this one, since we're not doing parallel arrays or two-dimensional arrays, we could actually do a range-based for loop. Let's do that. The syntax is simpler. For parentheses int v, like value, colon data, or we could have called it element, since that's what our pseudocode looked like. For int element in data, no if, we're just adding that to the total. Total equals total plus element, or total plus equals element. And then we could print the total out. You know how to do it if you were going to do it based on index. You do for I is equal to 0, I is less than size, I plus plus, and then total equals total plus data subscript I. So let's write out the total. Cout, arrow, arrow, total equals in quote, arrow, arrow, total, arrow, arrow, ENDL. And let's print out the average, which is just total divided by the size. But we need to convert one of those to a double or a float so that we don't get integer division. I'd like to know if the average was 200.5 rather than just 200. So cout, arrow, arrow, quote. And why don't I calculate it first? Double average is equal to double parentheses, total, end parentheses, divided by size. Right? We're casting it to a total. And size should have been in all caps. And then print that bad boy out. So, cout, arrow, arrow, quote, average equals, end quote, arrow, arrow, average, arrow, arrow, ENDL. I feel like testing that. Code block 5, even though it doesn't offer it. The total is 1203, the average is 200.5. Okay, that's almost creepy. Didn't I say that as my... Okay, anyways. I trust that those numbers are correct. I'm not going to actually add them up and see. I guess I could put in data that I can already figure out the average, like all 100s, and make sure that the average came out as 100, whatever. All right, next I want to write the code that will calculate the highest. Similar algorithm. It's going to use a for loop. It's going to initialize a variable, but it's going to have that if statement. If the element is greater than the highest, then highest is equal to that element. I don't want to blaze ahead, though, until I get the idea that nobody here is typing. Alrighty, let's declare a variable to hold the highest. Int highest is equal to the first element. Well, that's just data subscript 0. Now, do I want to use a range-based loop, a for-value loop, or do I feel like using an index loop? Doesn't really matter. Guess I'll use an index-based loop. For parentheses int I is equal to 0, I is less than cap size, all caps size, I plus plus. And then in there, if data subscript I is greater than the highest, data subscript I in subscript greater than highest, and highest equals data subscript I. Alrighty, and then I'm just going to print that out. Print arrow, arrow, highest equals, end quote, arrow, arrow, highest, arrow, arrow, India. That sounds right. I think my highest value was 674. I can eyeball it real fast and see. Yep. I've decided on a new bracing style to conserve space. Just put the opening brace in the code that follows it on the same line. Save me a whole 2 spots. Big deal. All right. Pause that. Alrighty, we have covered just about everything I wanted to cover in this chapter, even though it looks like we have another 20%. I'm going to come eyeball the chapter and see if there's anything else I want to lecture about. As always, read the entire book. Not the entire book, the entire chapter. Look at every page of the PowerPoint, even if I'm not covering it in here. Arrays with 3 or more dimensions. I'm not going to even cover that, but we know how to declare it. You just use 3 pairs of braces. 4 dimensions, 4 pairs of braces. Oh, now this is an interesting little fact. Are they saying that there's something weird about passing a 2-dimensional array to a function? They're implying that for 3- and 4-dimensional arrays. Yeah, check that out. Isn't that the world's most obnoxious thing? They want us to pass in. They want it defined. They want the function prototype to define the number of columns we're passing in. I'd kind of forgotten that you had to do that. I guess you certainly don't have to in Java. Certainly don't have to in, I guess I'm not going to talk about passing in 2-dimensional arrays into a function. That is so obnoxious. I can't believe that. I have to explore that. Sorry about that. You see our little code that printed out the array? I want to write that as a function if I possibly can. Where is our 2-dimensional array? That was code 4. Okay. So void print 2D, parentheses. It's going to be an array of strings. So string A, just for array, subscript, subscript, comma, int rows, comma, int calls. And it looks like maybe it really is already complaining about that. Man, that's annoying. Okay. Do you see why I hate that? I hate having to define the number of rows, the number of columns in my definition, either with a constant or a number, because that means I can't write a generic one that would be able to print an array that had 3 columns and then another one that had 10 calls.
Different function every time you want to print it.
Exactly. I'd have to have a different function for every differing number of columns. That's impossible to believe. I'm going to have to look into a better solution for that because the book shows this solution. And sure enough, it will not compile if I do that. But there's got to be a better way. All right. Keep looking at the PowerPoint, see what else. Summing the rows of a two-dimensional array. What's different than that than our first one? The only difference is that it's going to be two loops, right? For loop and then a for loop inside it. Same for the highest and the lowest value. I'm actually going to assign that rather than cover it in class. You'll be able to nab the code from the book, or I would recommend that you try to write it yourself. All right, and then lastly, introduction to the STL vector. If you've used Java, you know that there is a more flexible alternative to arrays, something that will grow and shrink as you add data or remove data from it. An array is fixed in length. Once you declare an array as being 4 items long, tough. It stays 4 items long. If you want it to be longer, you have to make a brand new array, copy all those elements in one by one. Same for deletions. You want it to suddenly be 3 items long because you remove something from the middle. You have to allocate a new array and then copy all the elements except for the deleted one into it. Tacky. Instead, you want a data structure that grows and shrinks. One of them is the vector. STL stands for Standard Template Library. So, the way you declare it, you have to first have the proper include, and there sure is skimpy amount of documentation for it, so we're not going to talk about it tonight. I'd have to make up more information than this. But anyways, you declare a vector like that. Just like in Java, you declare an array list like this. You say, I want an array list of strings. I'm going to call it AL for array list. But Java being Java, you have to do a little bit more than that. In C++, creating it is like that. Once you do that, then you can treat it just like an array. You can access all the elements with braces, but we need to add some data before we can do that. And so to add data, okay, here we go. You must include # vector. You can use pushback. That's an obnoxious term, but pushback means put something on the end of it. And then you can use the size function. It's actually a method since it's attached to a piece of data. This is a class. You can use the size method to determine how many items are in it, which is nice. Your for loops no longer have to have a constant. You do for I is equal to 0, I is less than array vector.size. Use popback to remove the last element from the vector. You can wipe out the entire vector. Just think of vector as meaning list. Use clear to wipe them all out. You can check to see if it's empty by calling .empty. A lot of these should sound familiar if you've done Python. You call .append to add items to the end of a Python list. You called del to pop an item off, or to delete the item. All right, we're not going to actually do that. We're not going to actually do that. So we're going to stop here. Let's look to see if I had any homework cooked up for you, but I'm really digging the idea of the one that I have in my brain right now. We've done a simple array assignment, I believe. We've done homework over arrays, that's correct?
Yeah.
Rainfall array, all right. Okay, those are boring. We're going to make our homework assignment. Homework. All right, homework. That will let the user enter a series of values into an array. 10 elements long. When they are done, print the array. That's the kind of prosaic one. That's part one. Part two, a little bit more interesting. Have your program allocate a 10 by 10 two-dimensional array. Fill it with random integers between 1 and 9. If you need help getting the random integers, feel free to Google. Feel free to ask me. I know we've used random numbers, so hopefully you can get that pretty easily. But like I said, feel free to ask me. If you get stuck on that, don't spend more than a couple minutes figuring that out. That's not the point of the assignment. And then print the array. Oh. When you're done, print the array, then print the total, the lowest, and the highest values in it. Same for part two. Print the array, then print the total, the lowest, and the highest. For a slight challenge, consider making the code print out a total for each row as it displays the array. Right. If that row says 1, 2, and 3, the total would be 6. If the next one says, 4, 3, 2, whatever that total is, 9. All right. That makes sense? Arrays homework? Anybody in a panic over that?
So basically, you're saying you basically want us to do like an input and have the user put the number with the arrays?
Right, right. You're going to allocate an array of 10, and then the user is going to enter those 10 numbers. Then you're going to print them out as an array and calculate the average and the highest and the lowest. Not the average. You could. The total, the highest and lowest. And since entering data for a two-dimensional array would be tedious, we're going to fill it with random data. Now, two-dimensional arrays are fun. If you're a game player, you probably have heard of roguelike games. What's the term roguelike mean? Well, back in the olden days, people would make games that look like this. It would draw a screen of a room. You would have a character. The @ sign is your character. You'd press up and down. You'd have some way of controlling your character, and you'd go and fight monsters and pick up items. That's done with a two-dimensional array. Eventually, he's going to head for one of the doors, and it's going to reveal the next part of the map. So what's happening is every time he presses the right arrow key, we're adding 1 to our column, our current, what column we're in. And every time he hits the up arrow, we're subtracting 1 from our row display. Now, obviously, there's a lot more to it than that. But that's neat.
So every time you move, is it just reprinting the whole thing?
Yes, most likely. Because I don't know a way. I know that you can backspace to print something new, and you could forward space to print something, but how would you jump up and down? So yeah, it's probably erasing the entire screen in order to redraw it, and we're just not seeing that flicker. It's kind of neat. I'd like to write a program like that. So I remember people actually playing these games. So this is Rogue, the first roguelike game. I don't know what roguelike games really are. I've never downloaded something that said it was a roguelike, but I guess it's some game where you're exploring. That would count Zelda as a roguelike. All right. Anyways, two-dimensional arrays are fun. You could make something like a Sudoku game where you were having to put in the numbers, or you could solve a Sudoku puzzle. You know, entered Sudoku and then it used some kind of math, you know, and kept iterating through it to find the possible combinations for it until it found a solution for it. You could spend weeks discussing that kind of stuff. All right, let's make a Dropbox, upload our stuff, and be done for today.